Hey guys, my name is Karthik Subramaniam. Just a quick introduction. I'm with MyFitnessPal, now UnderArmor Connected Fitness. We'll talk about that in just a second, and I wanted to introduce Pujit.
Hey guys, I'm Pujit, software engineer in the data science and engineering team at MyFitnessPal.
So today we're going to talk to you about sort of our approach with batch processing big data within MyFitnessPal. Just a quick show of hands from everyone here. How many folks have used MyFitnessPal before? Awesome. Keeping your hands raised. How many folks have used MapMyRun, MapMyFitness, any of those products? Awesome. Good. So I think the point is today we're going to talk about sort of MyFitnessPal and how we joined UnderArmor Connected Fitness very quickly. We'll talk about our data assets, our data platform, what are we trying to get to, what are we trying to solve for, and finally talking about our use cases, and then Pujit's going to walk us through sort of our common workflow to kind of help enable our platform, right? So just a quick introduction to MyFitnessPal. I think since most of the folks here have used it or seen it, the big takeaway here is we have over 90 million registered users. We have 7 million searchable food items and about 19 billion logged food entries so far. Back in March, we were acquired by UnderArmor, and with the acquisition, we joined two other companies, MapMyFitness, and then another company in Europe called Endomondo. And together, we've formed UnderArmor Connected Fitness. And we have about 140 million registered users across UnderArmor Connected Fitness. You can read all about it when we post up the slides. I won't go too much into the detail here. Well, so what does that mean for us today? Well, that means we started with food and nutrition information. So I talked about almost 20 billion logged food entries, 38 million recipes, 90 million users. And we're now combining that with a lot of workout and activity information. So we have, with MapMyFitness, we have a large user base that tracks over 600 different types of fitness activities. We have time series GPS data that includes geospatial data as well as real-time GPS data, which is a really interesting data set. We get music data with workouts. We also get activity throughout the day, which is for a user, which is very interesting. We also understand people's sleep patterns, and we get to kind of combine that with calorie information from MyFitnessPal and see what people are burning in terms of calories. And UnderArmor, if most of you are familiar, is traditionally been a retail company, and so we now have really interesting retail data that we can pull in to this as well. One thing I forgot to mention earlier, if you guys have any questions, please hold it till the end, and then we can try to help answer it, or I'll just let Pujit answer all the questions at the end. Some of the characteristics of our health and fitness data, as I mentioned, time series is really important. So you have wearables, sensors, GPS data, real-time, geospatial, and the list is continually growing, right? So we have a whole host of wearable technologies that are coming to market. We have this whole quantified self movement. So trying to get data is really important, and time series data becomes very important. And volume is really crazy. So we have about 20 million food logs that take place on a daily basis. And we also have bursts of data that happens, which is kind of interesting. So for example, you can imagine when there's a marathon or a race, scoping it to specific cities or regions, you have a burst of run or workout activity. And also a predictable pattern where at the beginning of the year, everyone makes a New Year resolution to say they're going to eat healthier, work out. So we actually have a growth in our data. So we have 3 times the volume of information and data that's flowing in through our system. But that's predictable year after year.
When is the least fit time of year?
I'm sorry?
When is the least fit time of year?
I will answer that question now,
Great.
but the least fit time of year really is around the holidays, as you can imagine. So we actually have Thanksgiving, and between Thanksgiving and New Year's usually tends to be the least fit time of year. So we have really interesting data sets. We have a growing data set asset. So we're now starting to think about how do we really build a platform to enable this growing, changing data set and volume of data. So this is influenced by Confluent, this graph, but there's really two big components of our data infrastructure. On the left side, you'll see Kafka, and on the right side, you'll see S3. So Kafka is our real-time data streaming platform, and S3 is our central repository. And the key component here really is down at the bottom, as most of you are aware. We're using Kafka for a lot of our real-time or near real-time streaming of information and processing of real-time data. And we want to use S3 for a lot of our offline batch processing of data. And we're supporting several use cases, one of them being business intelligence capabilities and various other use cases, which I'll get into in a second. A really cool example of, in our space at least, for real-time data that we're processing. So one of the ideas is we have this notion of campaigns. So, So we have campaigns where campaigns around fitness, where a user signs up for a campaign and then they log or trigger an event. That event gets fired, and then there's some processing that happens, and then push notifications for folks that have signed up for that campaign for that fitness get notified. So an example is like your friends get notified of the fact that you've finished a particular campaign around fitness. And then a use case around, for us, a use case around batch processing is really around weekly emails. So you want a user at the end of the week to get an email aggregating and summarizing their workouts, what they've eaten. That's a pretty classic example. So if we dive in a little bit deeper, particularly around storing our data. So one of our big focuses is really how do we move all of our data into S3 and centralize it so we can make it accessible. So we actually have Kafka sending data streams with app and service events. We also have third-party information that we want to store. We want certainly third-party information flowing in as much as possible through Kafka for the data stream, but there's going to be situations where we want to do snapshots of that data for batch processing. And the same is true for all of our relational databases, right? So we want the streaming of relational database information to go through Kafka, but there might be situations where we need to batch process it or take snapshots of the data. Now, once we have all the data centralized within S3, we use Hive Presto, which is enabled by Qubole, for a lot of our querying and batch processing. We want to enable data science use cases using Spark. Databricks is helping us with that, and certainly with business intelligence, we use Redshift as our analytics data warehouse. So given sort of the acquisition and the various sort of data sets and the centralized repository that we're moving towards, these are sort of just highlights around the problems that we're trying to solve and overcome. So first of all, we really want to build automation. So we want to get away from manual data replication and custom tooling around that. We want to provide standardization across all our data, so common data specs as well as directory structures across connected fitness data. And certainly around consistency, so we want to develop a common workflow to really enable health and fitness data, right? And the common workflow piece is what we want to dive into a little bit more, along with the use cases. So on this slide, best way to kind of read it is starting from the bottom up. So there's, I talked about some of the use cases, but just to dive in to the use cases a little bit more. We have a lot of analytics use case, certainly around business intelligence, right? So there's different business metrics that we need to provide, like DAU, MAU for different stakeholders. The other really interesting use case that we're trying to enable is user insights across apps. So now we have users that are on MyFitnessPal and the same users that are on MapMyFitness apps, right? So being able to connect the users behind the scenes and be able to provide them better user experiences within the apps is something that we're really thinking about. Certainly around data products. So one of the examples that we've listed here is around search improvements, where as foods are getting logged, we count the food logging, and then we promote certain food items based around how often they're logged, right? So that's an example of a search improvement we want to help enable with the data product. Certainly around data science, we have personalization and recommendation engines. So, for example, let's say you ate a banana for breakfast and had a burrito for lunch. What are some recommendations around food that we can make to help you stay within your goals and calorie information? And finally, to support data exploration use cases where you can allow ad hoc querying into our data source. And the common workflow, we're really kind of trying to think about it from the perspective of enabling batch processing and serving. So if you think about the raw and derived views, that's really supporting our batch processing capability, and our source of truth is really enabling our serving layer. And now I'm going to hand this over to Pujit a little bit to talk about, dive into the use cases some more and walk us through this workflow.
So I want to talk about an example workflow that we have and how we take data from Kafka to S3, and then how we leverage Qubole's capabilities to actually process that data. So as you know, data comes in as a data stream into S3. So the data that we have in Kafka comes in as JSON, and we want to store that in S3 in a particular directory structure. And the reason that we have this kind of directory structure is that it enables us to have data from multiple different data sources. Example, like we have MyFitnessPal, we have MapMyFitness, Untitled. So providing like the namespace directory is like really important, and tying that with the food type, the event type, like food entry created. So the reason that we have like the event type as separate subdirectory is because we don't want to store all this data into one like gigantic directory, and that will be like difficult for us to process that. And so we partition our this directory structure by date in R. So that enables us to have like hourly workflows or daily workflows. So here, like we have 20 million food entries per day, 2 million workouts logged per day. So like different events will have different volume coming in. And like then let's discuss like how we leverage Qubole's capabilities and use Hive to process data in S3. So first of all, like as we all know, we create external tables, map this schema onto the directory structure where we have the raw data living. So like we have time series data coming in via Kafka as streams. So like certain events might be batched up together, and so like that's why we have like an events array, so that like it allows us to like batch certain events together, and later on we have to like explode that into individual events. So now, what do we have? We have external tables containing data as raw JSON, right? We want to analyze that JSON, and that JSON is nested. We have to kind of flatten that JSON to process it in a like high performance. We want high performance on that. So we have like derived tables which stores data as ORC. So like in this example use case, like Karthik talked about, we want to enable data products, like we want to search improvements. So like let's say we want to count the number of times the food has been logged. So in this case, like we have food ID version, is it deleted or not, and when was the last modified. So we create this ORC table and we store it in this format. So now we actually take this data coming in from raw and move it to ORC. And this is where we do all the transformations from nested JSON to actual flattened ORC table. So the idea was to create a source of truth, right? We want to enable like people coming in, run Presto queries on source of truth for their analytics. So there are two types of events. Here, like we have transactional events and we have non-transactional events. So non-transactional events, an example for that would be like food search, food log, a session started, user entered, logged in, which like contains all the information right there on the event. As compared to as compared to transactional data, where we have like a resource was inserted, resource was updated, resource was deleted. So then, like once you have all these cases, how do you like combine the inserts, updates, deletes, and like the problem that we ran into, like combining these insert, update, deletes, and how we backfill the historical data. So like for relatively like small data sets, we took the reference implementation from Hortonworks, where like they ingest, reconcile, compact, and purge. So like you have these incremental data views, and you have a base table. You make a reconciled view, which actually aggregates, inserts, updates, deletes, and you put it into a base table. And then you purge the existing base table. So that kind of works for like relatively small data sets, but like it's not scalable for billions of records, and certainly does not fit our requirement. But we do that for like certain small data sets. And for larger data sets, we actually export that to asset databases like Redshift for now. But we are looking into better options there, like HBase or Cassandra. So like using this workflow here, like we analyzed using Presto on those food entries. And here you can see like the pattern of food entries in a month. And you can see like weekends people log less, and weekdays people log more. So yeah, so now we have Hive, Presto. When do we decide what to use, right? So Hive is good for batch processing. It has good capabilities for users to define their own functions. And it's good for large aggregations, as compared to Presto, wherein like we just use for interactive and ad hoc queries and for data explorations. So people like first go and use Presto. If it doesn't work for their use case, then they just use Hive. So like this is some query performance on workout data that we get from MyFitness. And like the best performing is like Hive on Presto on ORC tables, as compared to like Hive on ORC or Hive on CSV. So why, like, the question arises, why do we choose ORC? Well, we believe like ORC is the format going forward because, like, first of all, it has a columnar structure. It also has like enables us to do type-specific encoding, so that strings are compressed differently, integers are compressed differently, and there is single SERDE for all ORC files that we don't have to think about which SERDE to use. It has type-safe vectorizations, like any structure that we export in ORC has the type associated with it, and it works well with Presto. And the important thing here is that Hive 1.2 is going to have like asset support, and then it works with ORC formats only right now. So what's next? Well, we'll be updating to Hive 1.2 soon, which will have asset support, so that we can build source of truth tables in Hive, so that we can merge and insert, updates, deletes, make that source of truth, and like run Presto queries for exploration or Hive queries for large aggregations. So we now look forward to like choosing a better workflow manager and scheduler, and we are actively exploring options there with Pinball from Pinterest or Airflow from Airbnb, plus other options as well. And we want to make a self-serving data platform where anyone can come in, build their data pipelines, and it has to be like really easy for them to do that. So let's summarize. We're the world's largest health and fitness community. We have unique collection of data, mixing food, nutrition, workout, activity, and sleep. We have unique characteristics of data related to health and fitness. We have time series data, which is fitness, like workout data, fitness activities. We have real-time geospatial data as well. So what can we look forward to in future? Like, we have to build data infrastructure to support all these current and future needs. So as we all know, like, we all are moving towards a lot of sensors, with a lot of variables. How do we collect all that data and process that in the best way? And we are just getting started there. Thank you, guys.
So what software do you actually use to ingest into S3 from Kafka? Do you use Camus or use
So we use Printish implementation of CCore that basically consumes from all the Kafka topics and puts it into S3.
What is it called?
CCore. Yeah. Any other questions?
Why do you use the Kafka and not Flume?
Why do we use Kafka and not Flume? Well, we have a lot of people coming in from LinkedIn, and they like Kafka. and it works well as well. It's really scalable. There is no like hard requirements on number of topics you can have, number of partitions. We just keep on adding more nodes, and it's elastic. And that works well for our use case.
You're starting to get interest from the medical community to sort of cross-correlate health. Maybe depersonalize it, but
Well, definitely. Well, we have to see how the industry shapes up around this. Like, there's certain legal implications of how you share medical data as well.
Yeah.
So we'll have to see how we all evolve together. The health sector, fitness sector, how do we merge that together? So, yeah.
Yeah, that's the other question. Like, can you figure out if you actually lose weight by doing more exercise? Does exercise actually?
Yeah, sure. Why not?
Does it?
Yeah, I mean,
Can you prove it?
not now, but yeah, I mean, I think we certainly see one of the interesting things is we want to enable use cases where you can find correlation with the data and correlate it to user behavior. Right? There's a lot of factors involved, and it's not as an easy answer as yes, as I was kind of joking around and saying, but I think the data set gives you the ability to find just patterns in this to be able to make those kind of correlations. So.
Yeah, I was talking to a data scientist yesterday at a different meetup, and he was saying that one of the things that he felt like people needed to focus on in their work often was how they could basically improve things iteratively and how they could sort of keep on building out. So talking about your pipeline right now, what do you feel is sort of easiest for you to iterate on and change, and what do you feel is actually the hardest? Like, would it be easy for you to switch over to Flume from the Kafka, or is that kind of like a stuck, portion? Like, how do you feel flexible about that without getting?
Well, I think in our company, I think we are going to focus on Kafka, and we're not going to change over to Flume. That's one thing that's for sure. But other things, I think we are flexible about it, depending upon what we think is better.
I wasn't trying to stick to that specific example. It was just sort of in general, as somebody who's working there day to day. If you feel like there's particular sort of analytics or things that you want to run, that you have a hard time right now with the current setup, or if you feel like there's directions that are really easy for you to keep on pushing with the current setup.
Yeah, I can kind of take a stab at that. I think one of the things that we're always really mindful of is our platform and our tools enabling use cases that we want to solve for within our organization as well as the community, right? So the iteration is something that we're always thinking about. So it has to be use case driven, right? And are we running into any kind of roadblocks, and is the tooling in place able to provide that capability that we need to, or do we need to look at something else, right? And certainly, trying to look at principles around making sure that we are able to switch things out if we need to. That's part of the consideration of being able to move fast, right? And so, yeah, I think it's not a strong answer to say we have this one philosophy, but certainly something for us to think about as we grow. Our use cases have grown, and we've built on top of the system as well.
All right, thank you very much. We're going to have an unconference session afterwards. It's a great opportunity to ask more questions about what they're doing. I just want to transition over to the next speaker. Next speaker is Ashish from Qubole.